The sun, usually a welcome sight, begins to dim. It's not a cloud, not in the traditional sense. It is a living blanket stretching across the horizon. Millions upon millions of locusts, their wings beating in unison, blot out the sky. They arrive with a deafening roar, a symphony of buzzing wings and snapping mandibles. Below, a once fertile field of vibrant green transforms into a skeletal landscape, stripped bare in hours. This is not a scene from a horror film, but the devastating reality of a locust plague. These voracious insects, driven by an insatiable hunger, can consume their own weight in crops daily. For farmers, their arrival signals disaster, wiping out livelihoods and plunging communities into food insecurity. The locust plague is a stark reminder of nature's raw power, a force capable of both creation and catastrophic destruction. The air grows thick with the stench of these insects. Their droppings rain down like macabre confetti, a constant reminder of the relentless feast unfolding below. The ground, once teeming with life, falls silent, save for the crunching of mandibles. This is the grim reality of a locust plague, a relentless assault that leaves devastation in its wake. Throughout history, locust plagues have been recorded as far back as ancient Egypt, where they were seen as a divine punishment. Modern science has made strides in understanding these insects, yet controlling their swarms remains a formidable challenge. Locusts can travel up to 150 kilometers in a single day, crossing borders and affecting multiple countries. International cooperation is crucial in combating these plagues, as locusts do not recognize human-made boundaries. Innovative methods, including the use of drones and advanced technology, are being developed to monitor and control locust populations. Despite the challenges, there is hope. With continued research and global collaboration, we can mitigate the impact of these devastating swarms. The initial sighting of a locust swarm has always been a harbinger of doom. Historical records describe the panic and immediate reactions of affected communities. Communities would scramble to protect their crops, using any means necessary to fend off the invasion. The sight of the approaching swarm would send waves of fear and desperation through the populace. Locusts, despite their destructive capabilities, are fascinating creatures. They are in essence grasshoppers that have evolved a remarkable survival tactic, swarming. When environmental conditions are right, usually after periods of drought followed by abundant rainfall, locust numbers explode. This population boom triggers a transformation. The once solitary insects undergo a dramatic shift, both physically and behaviorally. Their color changes, their muscles strengthen, and they develop an insatiable appetite. They become highly social, drawn together by pheromones, forming colossal swarms that can stretch for hundreds of miles. This change, known as locust phase polyphenism, is a remarkable example of nature's adaptability. The once harmless grasshopper morphs into a formidable force, capable of traversing vast distances and consuming everything in its path. This dramatic transformation is key to understanding the devastating impact of locust plagues. Scientists have discovered that locusts communicate through a combination of visual signals and pheromones. Research is ongoing to understand the exact mechanisms behind their swarming behavior and to find ways to mitigate their impact. Genetic studies have revealed that certain genes are activated during the transformation, enabling locusts to adapt rapidly to changing environments. Understanding these genetic triggers is crucial for developing new strategies to control locust populations and prevent future plagues. One key factor in this transformation is serotonin, a neurotransmitter that increases in locusts during periods of crowding, triggering their swarming behavior. Environmental factors such as temperature, humidity, and food availability also play a significant role in this process. These factors, combined with genetic predispositions, create the perfect storm for locust swarming, making it a complex and multifaceted phenomenon. By studying these mechanisms, scientists hope to develop more effective methods to predict and control locust outbreaks, ultimately protecting agriculture and livelihoods worldwide. The sheer scale of destruction caused by locust swarms is difficult to comprehend. A single swarm can contain billions of individuals, with estimates suggesting they can consume enough food to feed 35,000 people for a day. The economic costs are staggering, often exceeding hundreds of millions, even billions of dollars, in lost crops and livestock. Beyond the immediate economic impact lies a deeper societal cost. Food shortages caused by locust plagues can lead to malnutrition, displacement, and conflict. The poorest and most vulnerable communities bear the brunt of these consequences, Trapped in a vicious cycle of poverty and hunger, the 2020 locust outbreak in East Africa serves as a stark reminder of the potential for devastation. Swarms of biblical proportions swept across the region, devouring crops and pastures, leaving millions facing severe food insecurity. The outbreak highlighted the interconnectedness of our world, with climate change creating increasingly favorable conditions for locust swarms to thrive. Historically, locust plagues have been recorded for centuries, with ancient texts and illustrations depicting their devastating impact. Modern science is working tirelessly to understand and mitigate these plagues, studying locust behavior and the effects of climate change. International collaboration and technological innovations are crucial in combating this ancient yet persistent threat. In India, the 2020 locust invasion destroyed over 50,000 hectares of cropland, causing an estimated $2.5 billion in agricultural losses. Similarly, in Pakistan, the locust swarms ravaged crops, leading to a loss of $2.2 billion and severely impacting the livelihoods of local farmers. In Kenya, the locust outbreak affected over 70,000 hectares of farmland, exacerbating food insecurity and economic instability in the region. Locust plagues are not a new phenomenon. They have plagued humanity for millennia, their devastating impact etched into historical records and cultural memory. The Bible recounts the story of locusts descending upon Egypt, a plague that brought the once mighty empire to its knees. This ancient tale serves as a stark reminder of the enduring threat posed by these insects. In more recent history, the Dust Bowl of the 1930s in the United States offers another chilling example. Drought and unsustainable farming practices created perfect conditions for locust swarms to thrive. The resulting agricultural devastation exacerbated the already dire economic situation, leading to widespread famine and displacement. Across different continents, locust plagues have left their mark. In Africa, Asia, and Europe, these swarms have caused untold suffering and hardship. By learning from the past, we can better prepare for the future and protect vulnerable communities from the devastating consequences of these swarming insects. Understanding the life cycle of locusts is crucial in developing effective control measures. From egg to nymph to adult, each stage presents unique challenges and opportunities for intervention. Migration patterns also play a significant role in the spread of locust plagues. Tracking these movements can help predict and prevent future outbreaks. International cooperation and research are essential in combating this global threat. By sharing knowledge and resources, we can develop more effective strategies to manage and mitigate locust plagues. Section 5. A sea of insects. To truly grasp the scale of a locust swarm, imagine a cloud the size of New York City, teeming with billions of insects. Now picture this cloud descending upon a field, stripping it bare in a matter of hours. This is not hyperbole, but the stark reality of a locust plague. The density of these swarms is astonishing, with estimates suggesting up to 80 million locusts can cram into a single square kilometer. Their sheer numbers can block out the sun, casting an eerie shadow over the land. The sound of their wings, a cacophony of buzzing and clicking, can be heard from miles away, a harbinger of the devastation to come. Their appetite is equally impressive. A single locust can consume its own weight in food daily. Multiply that by millions, even billions, and the potential for destruction becomes frighteningly clear. They are not picky eaters, devouring crops, pastures, and even the thatch roofs of homes. Farmers often resort to desperate measures, using smoke and noise to fend off the swarms, but these efforts are usually in vain. Locust plagues have been recorded throughout history, causing famines and economic hardship in affected regions. Today, modern technology and coordinated efforts aim to control these swarms, but the challenge remains immense. Scientists are continually researching locust behavior and breeding patterns to develop more effective control methods. Understanding the life cycle of locusts is crucial in predicting and preventing future outbreaks. The resilience of affected communities is remarkable, as they rebuild and recover from the devastation left in the wake of these relentless swarms. Eyewitnesses described the swarms as a living nightmare, with one farmer recounting, "It was like a black cloud descending, devouring everything in its path." Experts emphasize the urgency, with one entomologist stating, "The scale of these swarms is beyond comprehension. They can devastate entire regions in days." Section 6. Global hotspots. While locusts are found on every continent except Antarctica, certain regions are particularly susceptible to their devastating swarms. These locust hotspots are typically characterized by arid and semi-arid climates, where periods of drought are followed by sporadic rainfall, creating ideal breeding conditions for these insects. Africa, the Middle East, and parts of Asia are particularly vulnerable, with locust plagues posing a recurring threat to food security and livelihoods. The Horn of Africa, in particular, has been ravaged by several devastating outbreaks in recent years, highlighting the urgent need for effective control measures in these vulnerable regions. Climate change is exacerbating the problem. Warmer temperatures, altered rainfall patterns, and more frequent extreme weather events are creating increasingly favorable conditions for locust swarms to thrive and spread. This global challenge requires a coordinated international response to effectively monitor and control locust populations. Historically, locust plagues have been recorded for thousands of years, with ancient texts and illustrations depicting their devastating impact on civilizations. Today, advancements in technology such as drones and satellite imagery are being utilized to monitor and predict locust movements more accurately. Scientists are also researching locust behavior and breeding patterns to develop more effective control strategies. Community education programs are essential in teaching locals about effective locust control methods and the importance of early intervention. International aid and relief efforts play a crucial role in supporting affected regions and mitigating the impact of locust plagues on vulnerable communities. Recent data shows significant locust activity in regions such as East Africa, the Arabian Peninsula, and South Asia, with outbreaks causing widespread damage. Satellite images and time-lapse footage reveal the rapid spread of locust swarms, emphasizing the need for timely intervention. Global response teams are working tirelessly to control these outbreaks, but the scale of the problem requires continuous international cooperation and support. Section 7. Fighting back. Controlling locust plagues is a constant battle, one that requires a multi-pronged approach. Traditional methods involve spraying insecticides, often from aircraft, to target locust swarms directly. While effective in the short term, these chemical interventions can have negative environmental impacts and pose risks to human health. New technologies are emerging, offering more sustainable and targeted solutions. Biopesticides derived from natural sources offer a more environmentally friendly alternative to synthetic insecticides. Remote sensing technologies, including satellites and drones, are being used to monitor locust populations and predict swarm movements, allowing for more targeted and timely interventions. Early warning systems are crucial in the fight against locust plagues. By accurately predicting swarm movements and potential outbreaks, authorities can mobilize resources and implement control measures before significant damage occurs. International cooperation is essential, as locust swarms know no borders and require a coordinated global response. Community involvement and education are also key components, empowering local farmers with knowledge and tools to protect their crops. Learning from past experiences, modern strategies are continuously evolving to become more effective and less harmful to the environment. The fight against locust plagues is a collaborative effort, bringing together scientists, governments, and communities to develop innovative solutions. Section 8. An unexpected silver lining. While locusts are primarily known for their destructive capabilities, they do offer some surprising benefits. In certain cultures, locusts are considered a delicacy, a valuable source of protein. They are also used as animal feed, offering a sustainable alternative to traditional protein sources like soy and fish meal. From a scientific perspective, locusts provide valuable insights into insect behavior, particularly the fascinating phenomenon of swarming. Understanding the complex interplay of environmental factors and biological triggers that drive swarm formation could have implications for other areas of research, such as crowd dynamics and artificial intelligence. However, it is crucial to acknowledge that these limited benefits pale in comparison to the widespread devastation caused by locust plagues. While exploring alternative uses for locusts is worthwhile, the primary focus must remain on preventing and controlling their devastating swarms. In many regions, traditional methods are still employed to combat locust swarms, highlighting the ongoing struggle faced by farmers. Community involvement and local knowledge are essential in developing effective strategies to mitigate the impact of locust plagues. International cooperation and aid play a vital role in supporting affected communities and enhancing locust control measures globally. Interestingly, some ecosystems have shown resilience, with certain plant species regenerating more robustly after locust swarms, potentially leading to greater biodiversity. Additionally, the challenges posed by locust swarms have spurred advancements in pest control research, leading to more effective and sustainable solutions for managing agricultural pests. Gap 3S, Section 9, the long-term ecological impact. While the immediate devastation caused by locust plagues is evident, the long-term ecological consequences are often overlooked. These swarming insects strip the land bare, leading to soil degradation and loss of biodiversity. The natural balance of ecosystems is disrupted, affecting everything from plant regrowth to animal populations that rely on these plants for sustenance. Over time, this can lead to desertification, turning once fertile lands into barren wastelands. The introduction of invasive plant species can further alter the plant community, leading to a decline in native species and a shift in the ecosystem structure. Changes in the food chain can occur, affecting predator-prey relationships and leading to imbalances. The water cycle can also be impacted, with reduced vegetation cover leading to altered water retention and increased runoff. Soil nutrient depletion can make it difficult for future crops to grow, perpetuating a cycle of poor agricultural productivity. However, innovative biopesticides are being developed, targeting locusts without harming other insects and wildlife. These biopesticides work in harmony with nature, breaking the cycle of destruction while preserving the ecological balance. Community-based initiatives are also gaining traction, empowering local farmers with sustainable agricultural practices that enhance soil health and resilience against locust invasions. Imagine a future where ecosystems thrive, free from the threat of locust plagues, where technology and nature work hand in hand to protect our environment. This vision is not just a dream but a tangible goal. By embracing scientific advancements and fostering global cooperation, we can create a world where the long-term ecological impacts of locust plagues are a thing of the past. Together, we can build a sustainable future, ensuring the health of our planet for generations to come. Historically, locust plagues have been recorded for centuries, with ancient texts and illustrations depicting their devastating effects. Traditional methods of locust control were often rudimentary and largely ineffective. Today, modern agricultural practices and integrated pest management strategies offer more sustainable solutions. Educational programs and workshops are essential in spreading knowledge about these advanced techniques. Community-led initiatives, supported by local leaders, play a crucial role in implementing these practices on the ground. International conferences and collaborations among scientists are vital for sharing research and developing new strategies. Successful case studies from regions that have recovered from locust plagues provide valuable insights and hope for affected areas. Future technologies and innovative solutions continue to be developed, promising even more effective ways to combat locust plagues. With global cooperation and united efforts, we can overcome the challenges posed by locust plagues and protect our ecosystems for the future. Section 9. A future free from famine. The specter of locust plagues, a timeless threat to human civilization, continues to loom large. However, there is hope. Advancements in technology, coupled with increased global cooperation, offer a path towards a future where the devastation caused by these swarming insects is a relic of the past. Imagine a world where locust outbreaks are detected early, their movements predicted with pinpoint accuracy. Drones equipped with biopesticides target swarms with surgical precision, minimizing environmental impact. Farmers, empowered by early warning systems, take preventative measures, protecting their crops and livelihoods. This vision, while ambitious, is achievable. By investing in research, fostering international collaboration, and embracing innovative technologies, we can break the cycle of locust plagues and ensure food security for generations to come. The fight against locusts is a fight for a more sustainable and equitable future, a world where the threat of famine no longer hangs over vulnerable communities. Education and community engagement are also crucial. Farmers using mobile apps for real-time locust tracking and participating in community workshops can make a significant difference. Governments play a pivotal role by implementing effective policies and supporting international summits focused on agricultural sustainability. Educating future generations about locust control ensures that the knowledge and practices continue to evolve, securing a better future for all. Ongoing research into genetic and biological control methods promises groundbreaking solutions, potentially altering the locust's life cycle and reducing their ability to swarm. Future strategies include a global network of monitoring stations, sharing real-time data to predict and prevent outbreaks before they start. By integrating advanced farming techniques and developing resilient crops, we can create a robust agricultural system capable of withstanding locust threats. With visionary leadership and unwavering international cooperation, a future free from locust-induced famine is within our grasp.